Good morning everybody, myself Vishvendra and I am the founder of Optimal Success Trajectory. Today we will discuss about springs. So there is a concept of equivalent spring constant. Suppose there are more than one springs and they are connected to a block of certain mass m, then let that the system extends by x and it applies a certain force F on the mass m. Then equivalent spring means if we replace all the combination of springs by a single spring having a spring constant K equivalent, and because of which under same extension x the applied force by the system is equal to the force applied by a single spring. So this is the concept of equivalent spring constant. So we have two cases, the first is series combination and the second is a parallel combination. So let's deal with the first case. So in series combination, how we will know that springs are connected in series? So springs are said to be connected in series when there is a single point connecting the two springs. If there is a single point connecting the two springs and the restoring force has same magnitude in both the springs, then we say springs are connected in series. Just like here there are two springs, K1 and K2 are the spring constants, and there is a single point connecting these two springs and they are connected to the mass. So if there is such a combination, then we say springs are connected in series. So let us suppose that we replace these two springs by a single spring having a spring constant K equivalent. So by equating the forces in the two cases, we have this equality 1 by K equivalent is 1 by K1 plus 1 by K2 for two springs, and for n springs you just add them up to n. This is the harmonic mean of individual spring constants, and by mathematical equality we can say that K equivalent is minimum in case of series combination. The proof we have omitted because it's not needed, but as a it has been calculated by equating the forces in the two cases. Now let's move forward to the parallel combination of springs. Springs are said to be connected in parallel if same extension is there. So if you stretch the mass, then extension will be same in both the springs. Then these are said to be connected in parallel. Again, by equating the forces, we have the result. K equivalent is K1 plus K2, this is for two springs, and K equivalent is K1 plus K2 up to Kn, this is for n springs. And K equivalent of springs is maximum in parallel combination. So we studied today that there are two popular ways of connecting springs. The one is series combination and the second is a parallel combination. In series combination, there should be a single point connecting the two springs, and in case of parallel combination, the extension should be same in both the springs. K equivalent is minimum in series and maximum in parallel combination. So this was all. I think this will help you in solving your questions quickly. Thank you and have a nice day.